In this example, we're looking at solving the literal equation x equals k divided by k minus v for k. Now this example is a lot more involved for the simple reason of we have k in both numerator and denominator. This is a special case here where we're going to have to figure out a way to get k by itself, even though there are two of them on the same side of the equal sign. So the first thing we want to do is, just like we saw before, we want to dig out this first k in the denominator. And the only way we can do that is by multiplying both sides by that k minus v value. Okay? So when I do that, I'm going to put parentheses around it on the right side as well as on the left side. So k minus v goes away on the left side. That cancels out completely. I'm going to start a column over here on the left because we're going to need a lot of room to solve this. So I'm left with, after I apply the commutative property of multiplication, I'm going to end up with x times k minus v, and that's equal to the only k that I have left on the right side. Okay? So keep in mind, we want to get k by itself, and we want to get all of our k's over to one side. What I'm going to do is I'm going to move the k on the right side of the equation over by subtraction. So minus k minus k. Now, unfortunately, because this k right here is in parentheses, I can't combine it with the k I just subtracted. But let's go ahead and take a look at what happens here. So k's cancel, gives me 0. It doesn't just go away, it gives me 0. And I'm left with x times k, x times k. Let me erase that, not x times x times k. If my pen would work, that'd be great. X times k minus v minus another k equals 0. All right. So now we're kind of at a crossroads here. What do we do now? Well, we got to get this k that's in parentheses out so we can combine it with this k here. So I'm going to go ahead and distribute my x to the k and the v inside here. I'm left with xk minus xv minus k equals 0. Okay, so now I have an opportunity to get the k's on one side and everything else on the other. And the way I'm going to do that is I am going to get rid of my xv by adding it. So add xv, add xv. When I do that, my xv's cancel. On the left side, I'm left with xk minus k equals my positive xv. So right here, I'm going to go ahead and put that in my next column over. So xk minus k equals xv. Okay. So now I'm at a point here. I'm at a crossroads where I've got to figure out how to make two k's become one of them. And I look at the two terms that I have on the left side, which I have an x times k and a singular k by itself here. If I have a common number, common factor, common variable between two terms, I can factor that variable out by using technically what's the reverse of the distributive property, but it's called factoring with the greatest common factor. So I take out my common factor, which is k, and I look at what's not in common between the two terms. In this case, it's just going to be my x. I have a minus sign, and I take the coefficient of my k, which, because it's only one of them, is going to be minus 1. Now I have only one k instead of two of them. I'm going to go ahead and divide by x minus 1 to get k by itself, because x minus 1 is just a number. My x minus 1's cancel on the left side. I'm left with k equals x times v divided by x minus 1. So once again, this was an example of what you can do when you have a literal equation with the variable you're trying to solve for in both the numerator and denominator of a literal function.